Okay, it's 6:05. Uh, we can start the sessions now. My screen is visible to you. I have shared my screen. Hello.
Yes, it is visible.
Okay. Uh, Hello. Good evening to you all. This is Subrata Kumar Maiti, PhD research scholar, IIT Roorkee, course instructor, Professor Pratibha Sharma, IIT Bombay. Uh, Course name is Hydrogen Energy Production, Storage, Transportation, and Safety. Okay. This is the week 2 lecture series from my side, and today I will discuss about the topic whatever the week 2 series lecture series discussed by ma'am. Okay, just wait. And we'll discuss some assignments, and we'll discuss one numerical that ma'am has already discussed. Okay, and we'll solve some MCQ question type 2. Okay. This was the week 2 lecture covered, topic covered. The topic was the lecture from the lecture 8 to lecture 13. Okay. Uh, in the advanced method of steam reforming, advanced method of steam method. एक second, 1 minute. 1 second, just I am taking my pen. Okay. In the lecture 8, advanced method of steam reforming, that means initially in the first week we have studied the SMR reaction, steam methane reforming process. This was the part of advanced method of steam reforming, means how we will do some arrangement, some sort of arrangements. That's why we will enhance the reactions, rate of reactions, or you can say the productions of hydrogen rate, or you can say that the hydrogen by carbon monoxide ratio. Okay. uh, in this point of view we will think about the first lecture, lecture 8, advanced method of steam reforming. Next is the partial oxidation method for hydrogen productions. This is one another topic or another process of producing hydrogen, where partial oxidations mean substoichiometric quantity of oxygens is required or necessary to generate hydrogen productions in the reactions. Okay. Next is the lecture 10, autothermal reforming process. In this autothermal reforming process, what happened? The means the name itself suggests that autothermal means that the something is adjusting that in terms of thermal energy. That means the some reactions is like endothermic reactions, and some reactions is exothermic reaction. Somehow the thermal energy is adjusting That's why its name is autothermal reforming process. Next, lecture 11, combined dry by dry reforming. In the above topic or process, we have seen that only one oxidant was used. Okay, like in the SMR reactions, what was in the SMR reactions? Okay, in the SMR reactions, the oxidant was water, means that the vapor. Okay, the vapor. And partial oxidations, partial oxidations method. The oxidant what is the oxidant used in partial oxidations method? Do you remember? It is oxygen.
Oxygen, yeah.
It is oxygen. Okay, oxygen. Okay, and in autothermal process, it is also oxygen. Okay, and sometimes steam is used. Okay, next, combined dry and by dry reforming means that the here the oxidant is more than one oxidant. Okay, more than one oxygen or more than two oxidant. Okay, what is the oxidant used for the bi and tri reforming? Here also oxygen and water vapor. Okay, oxygen, water vapor, and sometimes carbon dioxide. Okay, carbon dioxide is also used for producing hydrogen. Okay, for the tri reforming case. Okay, and in the last lecture and the lecture 12, you have studied that some alternate energy source means that the uh, so far we have discussed that autothermal reforming process, combined dry and by dry reforming process, we have used the external heat supplied or external heat source in terms of thermal energy which is required to run the reaction. Okay, what was the external heat source we have used? You know that the methane. Okay, methane plus oxygen, the burning the methane and oxygen was used as a fuel which produce heat energy. This heat energy is used for the reaction in the reactor. Okay, but here the alternate energy means that just to conserve the methane. Okay, just to conserve the methane means what are the alternate energy source that we can use to provide the heat in the reactor chamber? Okay, what are the alternate energy source? Like it's maybe electric source, it's maybe renewable source like solar energy. Okay, it's maybe other energy. Okay, like wind energy, biomass energy. This is the alternate alternate energy we can use. Okay, and 13th lecture was tutorial part. This was wholly dedicated to one numerical. That numerical I will also discuss. Okay, next, just let me check. Anyone is trying to join, I think. One request from my side actually, please join in time such that uh, it is beneficial for you as well as from my side too. Okay, the aim of the sessions, you know that we'll discuss all the lecture covered by ma'am. Okay, we'll discuss the basic doubts also. Okay, and we'll discuss some sort of problem also. Okay, okay. whatever we study, whatever we study with the SMR reaction, steam methane reforming. This is the steam methane reforming process. What was the fourth different step of the steam methane reforming process? Do you remember? Four different. Anyone of you? Hello.
Yeah, first desulfurization.
Yeah, that is called pre-treatment. Okay, desulfurization. Very good. Next, next is the SMR reactions, steam methane reforming reaction, reforming reactions actually, reforming reaction. Next,
Water gas reaction.
water
Shift to it.
water gas shift reactions. That means carbon monoxide water gas shift reaction. Okay, that produce carbon dioxide. Okay, water gas shift
Purification.
shift reaction. Okay, fourth one is the
Purification.
purifications. 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 These are the basic fourth step. You should remember actually. Huh? What are the four steps involved in the SMR reactions? Okay. Here, why we are going to study the conventional? Why we are going to just modify the this sort of conventional reforming process? It has obviously some challenges. That challenges we are addressing here. Okay, just we are here trying to recover, modify. By modifying some things we will trying to recover these challenges. Okay, before that, before coming to that, we should know the challenges with the conventional reforming. Conventional reforming means the SMR reactions. Okay, conventional reforming, in the conventional reforming process, it was the reactions is highly endothermic reactions. You know that the 206 kilojoule per kg, kilojoule per mole, okay, heat is required for producing, 3 mole, for producing hydrogen. Okay, this is endothermic reaction. Okay, heat is required, and the overall process is very complicated. Why the overall process is very complicated? Because these are the lot of steps involved in this process. Okay, we want, okay, we do not want the complicated things. Okay, and all the complicated, all the four steps involves in the SMR reaction need a large amount of the space and large amount of instrument, and it is very complicated. It's not at all flexible in terms of design. Okay, and the integrations related challenge means that the all the process of integrating of all the process is very difficult for the conventional reforming process. integrating means Integrating means compact design. Okay, everything we want in industry, that is the compact form. Okay, we do not want scattering type of design, scattering type of instrument here and there, and we will produce hydrogen. Okay, we should focus a very compact product such that hydrogen, anything for the waste things, industry needs optimum locations or optimum place. Okay, these are the things, endothermic reactions and exothermic reactions, you know. And exothermic reaction, water gas shift reactions is a exothermic reaction. Just you remember, water gas shift reactions is a exothermic reaction, and endothermic reactions is the SMR reactions is the endothermic reactions. Okay, that's why in endothermic reactions heat is required, and exothermic reactions heat is released. Okay, the two contradictory things, heat required and heat release, the two processes occurred at two different places. Okay, it is very difficult to handle the, or it is very difficult to manage the, to thermally, to manage the thermal, thermal management. Okay, that's why these are the sort of challenges with the conventional reforming process. Whether okay, once I don't know. Okay, just this is the last time I am accepting. Uh, I mean, let me accept the students here joining here. Okay, okay. Okay. Next is the this was Acha. First thing, just we have to remember that what what modifications we can do such that what modifications we can do, the rate of rate of hydrogen productions will be high. The rate of hydrogen productions will be high. The rate of hydrogen productions will be high. Okay. In the conventional process, what are the lagging point? That the productions of the hydrogen was less, thermal management was very difficult. Okay, we have to arrange the reactions in such a way that the productions of the hydrogen will be high. That means hydrogen divided by hydrogen gas divided by carbon monoxide ratio is high. We always want that we always want the hydrogen gas divided by carbon monoxide, the formations of the carbon monoxide is high. Okay. So what is the reactions? What is the SMR reactions? The SMR reactions is this. This is the SMR reaction. Methane. Okay. CH4 plus water H2O. Okay. This is the carbon monoxide. Carbon monoxide plus hydrogen. Okay. How do you know how can I increase the how can I increase the reaction rate? How can I increase the reaction rate? If the reaction rate, the reaction rate means that the productions of the hydrogen should be high. How can I increase these productions of the hydrogen? There are only two process, not only the two process here for the two process. If I if I if I somehow arranging something, if I take out, if I remove, or if I store, or if I take the hydrogen gas out from the reaction chamber, the rate of reactions of kinetic of the reactions will be high. Okay. Here, this is the same thing that, or okay. Here one thing is used, or carbon. Okay. Or the here produce the carbon monoxide or carbon dioxide. In the reactions, actually it produces carbon dioxide formation, carbon carbon dioxide formations is also occur. Okay, sorry, carbon dioxide formations is also occur. If I just reduce carbon monoxide or carbon dioxide too, you will see not only one reactions will be occur in the methane reforming, there are the multiple reactions will occur. If we, I mean, if we remove the outlet product gas, or if we absorb this outlet product gas, the kinetics of the reactions kinetic will be favored. Okay, here the some adsorbent is was used, some adsorbent is used to adsorb this sort of carbon dioxide, okay, or some other gases, or carbon monoxide or hydrogen gas. If we adsorb this sort of gas, okay, the kinetic will be favored and the rate of reactions will be higher. Okay, here the reactions, in the reaction, here you can see, here you can see this is the reaction. Okay, this is also, this is this is also SMR reaction, but here one extra term adsorbent is used. Okay, A is adsorbent is used. Okay, A is adsorbent is used. It will adsorb carbon dioxide produced in the reactions. Okay, it will produce carbon dioxide in the reactions after water gas shift reaction. Okay, this is here the carbon monoxide is produced after water gas shift reactions. It will produce carbon dioxide. If we absorb this carbon dioxide gas, the rate of reaction, the overall rate of reactions will be high. That's why here one adsorbent is used to absorb this carbon dioxide gas. Okay, and the for in this way the rate of reactions will be high, and also the purifications of the hydrogen gas will be done. Okay, and these are the some data here, that is 0.79 gram of carbon dioxide adsorbed by per 1 gram of CaO. Okay, limestone. Okay, the some, so there are different adsorbent used. The different adsorbent used is the one is the limestone. CaO is very good adsorbent. Okay, CaO is very good adsorbent. CaO adsorb carbon dioxide, CO2, it will produce CaO2, CaCO3. Okay, just to remember the name of the adsorbent used in the sorption enhanced reforming. This is the CaO. Okay, how this process is occur here? The process is same as it was in the before. Okay, just let me wear one gloves. The writing is difficult. Okay, the reaction process is almost similar kind of reactions process. Here the inlet feedstock, feedstock, this is the feedstock, this is the feedstock, CH4 and water. Okay, water is the feedstock, it is coming into the reactor. Okay, in the reactor, with the help of the catalyst, it will produce syngas, hydrogen gas and carbon monoxide. Okay, and and here what is happening, here water shift gas reactions is also there. Water gas shift reaction, water gas shift reactions is also happening here. And what will happen, one CaO is used to adsorb the carbon monoxide produced from the water gas shift reaction, and it will form CaCO3, and this CaCO3 will again regenerated in another chamber. Okay, and this is very the regenerations of the CaCO3. The regenerations mean the CaCO3, CaCO3, it will regenerate it, and again it will produce CaO, and this CaO again is used in the chamber. Okay, in the reacting chamber or reforming chamber. Okay, this this regenerations of CaO is a very high energy intensive process. It requires very high temperature. Okay, this is required all this is 885 to 975 degrees centigrade. I means that the regenerations of the CaCO3 to make CaO is very difficult. It requires high temperature, and one extra unit is also required. Okay, our main motto was just to first the kinetic reaction such that hydrogen productions will be high, such that we have added one adsorbent like CaO. This CaO absorb carbon dioxide such that reactions will be high, but the regenerations of the carbon CaO is very high. It is not so much actually good process. Okay, this is some uh, disadvantages of this process. Okay, the benefits of the subsumption enhancement reforming, here the listed. Okay, you can see. Okay, uh, this is the fewer processing step. Okay, no need of water gas shift reactions in terms of in extra unit. There is no need of water gas shift reactions. All the things is occurring inside of the uh, reaction chamber or reactor. Okay, this is the comparatively low temperature operation process. Earlier it was higher temperature operation process, but in that case it is 600 or 650 degrees centigrade. Earlier it was above 900 degrees centigrade. The SMR reactions is the SMR reactions was 750 to 900 degrees centigrade or above 950 degrees centigrade. But here the sorption enhancement reforming process is below 750 degrees centigrade or 650 degrees centigrade. Okay, the less heat is required or less temperature, low temperature operation process. This is the low temperature operation process. Okay, and purification step is simpler. Okay, the purification step is simpler means that the will use CaO and it will absorb carbon dioxide gas. The carbon monoxide, the mixture, the hydrogen gas is we can generate much uh, much purity of the hydrogen gas. Okay, but the challenges associated with the SER process, high heat required in the regenerations of the CaCO3. Okay, this is a very high energy intensive process of generating, but we cannot use CaO. We cannot buy CaO repeatedly. Okay, we have to regenerate in any industry, any chemicals or any materials. Okay, generally they wants the regenerating form or recycling form. We generally they will regenerate or recycle the chemicals. Okay, such that the operation process or opex will be less. Okay, this was part earlier part was the adsorption process of the carbon dioxide gas. If we adsorb the carbon dioxide gas, the kinetics of the reactions will be higher. But if we adsorb the hydrogen gas or if we separate the hydrogen gas, the reactions will be high. Okay, the another process here, this is the another process is the hydrogen membrane reactor. Okay, in this case what happened, in this case one one channel one channel means that the it is made of membrane. This is actually membrane. Okay, This is membrane. This is membrane. Membrane means, uh, what do you mean by membrane? Do you know what do you mean by membrane? What is the function of membrane? This is membrane in coaxial, not coaxial, uh, eccentrically arrangement. This is eccentrically arrangement. Eccentrically arrangement means, in one hollow chamber another hollow cylinder is fitted like this. Okay, okay, like this. This the inner hollow part is the membrane. What is the membrane, do you know?
It will allow only one either element or any substance to pass on.
Exactly, exactly. The membrane, the working principle of the membrane is, membrane will allow only one particular substance, one particular substance he can allow, and another particle will not allowed by the membrane, such that we can desalinate, or we can remove, or we can separate the different particle in the different form, like simple straining means that the during straining means, when we'll make some tea leaves and water. Okay, the tea leaves will be kept upper side, and your tea, I mean tea will be in the in your cup. Okay, the upper part will be, the upper part is called retented. Upper part is called retented. Okay, this is called retented. Okay, retented. This actually, here this is the retented. This is the retented part, and whatever permeate through the membrane, it is called permeate. Okay, this is means that the hydrogen gas is here. In the case, hydrogen gas is giving permissions to allow this through the membrane. Okay, okay. So the hydrogen gas is permeated. Okay, this is the hydrogen gas. What is happening? The outside cylinder, the outer cylinder, here this is the outer cylinder, here the reactions is happening. Okay, here the SMR reactions is occurring, and the basic principle of our main motto is just to remove one of the product mean here hydrogen. Okay, here the if we somehow separate the hydrogen from the product means other product like carbon monoxide, carbon dioxide gases. If we allow, if we separate hydrogen gas through membrane, okay, through membrane, the other product will be remaining here, and other product will be permeated through this, and the combustion gases also permeated through the here, and the hydrogen gas will be separated. This hydrogen gas is, we can also produce as a cleaner hydrogen through the membrane separations. Okay, ultimate motto is that, just to separate the one product such that the rate of the kinetics will be higher. Okay, this is packed bed membrane. Here packed bed membrane means, here the catalyst is packed with a support, and this that's why the packed bed membrane. And there are another kind of the things is the fluidized bed. In the fluidized bed, there also catalyst is used, but what thing the catalyst in the fluidized form, I mean whatever the air will give to the reaction chamber, the air will be high speed and high pressure air. Okay, in the power plant case, there actually what happened in the fluidized bed, this is suppose boiler, this is boiler, all the things arrangement here. Here the in the fluidized base, something, suppose the coal is used for the packed bed things. this is packed bed, the lump size coal is used, okay, and the burning is happening here, okay. This is not a proper burning, or this is not will be proper uh, heat generation. But in the fluidized bed, what happen, the air and very dusty particle or very small dimensions coke, okay, coal is fluidized into the reactor, okay, and air and the coal particle very smaller dimensions, smaller dimensions coal particle, like this is very smaller dimension. Why this smaller dimensions coal particle is used in the fluidized bed? Because the surface area will be high, okay. For the lump size coal, the surface area is this much, but when we will break it into very small pieces, the surface area will be high, and the heat production will be very high. And that's why the fluidized bed concept is used for every reactor, okay, starting from the power plant industry, and here in the hydrogen gas reactor, okay. What is the membrane material? Material is the palladium, okay, okay. And what is the advantages, disadvantages, okay. Membrane material also may uh, contain some impurities, and this is some membrane is the some expensive material, okay. This is the things, okay. Benefits of this hydrogen membrane reactor. This contain this is a fewer processing steps. It contains very less processing steps, okay. Higher methane conversion means that the higher hydrogen production, okay. uh, Temperature is little lower, okay. The product of the hydrogen is pure, as I am separating the hydrogen through the membrane based separator, okay. Only the membrane is allowing the hydrogen gas only, okay. It reduces cost, okay, comparatively, and energy consumption is also less in this process, okay. The footprint means that there are less carbon footprint, okay, or less CH4 is used to produce hydrogen gas, equivalent amount of the hydrogen gas, okay. The challenges associated with the hydrogen membrane, this is a membrane, actually sometimes membrane will be blocked, okay. That's why when the membrane will be blocked, the hydrogen gas will not permeated through the membrane, okay. And in this process, in this case, this will not suitable, and the efficiency will goes down, okay. And next is the another process. This is the partial oxidation process. The name itself suggests that partial oxidation process means partial means not full, okay. Partial mean not full. That means not, that means substoichiometric reactions, okay. Here the oxygen is used, okay. Less amount of the oxygen is used, okay. Earlier the oxygen mole was higher than half, okay, but here the oxygen is used, only half molar oxygen is used, okay. And it produces carbon monoxide and H2. This is the syn gas. Here but this is endothermic or exothermic reaction. The minus sign is here. This is exothermic. This is exothermic reactions, okay. This is exothermic reaction, and CH4 I mean only minus 36 kilojoule per mole, okay. And this is also CH4 plus oxygen it will produce, if the larger amount of the oxygen or sufficient amount of the oxygens will be used, it will produce larger amount of the heat, that is the 802 kilojoule per mole. This is important, actually you just remember 30 kilojoule per mole or 802 kilojoule per mole. Okay, when it is produces carbon dioxide. Okay, this is partial oxidation process. Okay, there are two type of partial oxidation process: non-catalytic process and catalytic process. Non-catalytic process, the name itself suggests that the no catalyst is used for that case. Obviously, as the no catalyst is used here for the non-catalytic partial oxidation process, the higher heat is required. It will, the temperature is almost 1200 degrees centigrade or 1500 degrees centigrade. Okay, non-catalytic case. For the catalytic, if we use the catalyst, for the partial oxidation process, the temperature, the reaction temperature will be less. It is 600 to 900 degrees centigrade. You just remember these things also. Okay. Here, what is the oxidant here? Oxidant is oxygen. If we use air, the oxidant will be all the compositions of the air, like starting from oxygen, nitrogen, carbon dioxide, all the things. Okay, in the air, the large amount of the nitrogen is used, but nitrogen will not participate in the reactions. Nitrogen will stay as it is. Why we will use nitrogen? Why we will use air as a oxidant? Do you know? AIR, air as a oxygen. Air means oxygen plus nitrogen. Sometimes we will use air as an oxidant in the partial oxidation process. Why? Sometimes it is depend, it will depend on the productions. It will depend on the end applications. Okay, what is the end applications of the hydrogen gas? If the end applications is the NH3 ammonia process, ammonia synthesis, then nitrogen is required. The nitrogen, obviously, if the nitrogen is stay in the hydrogen mixture, it is good, no problem. Okay, if the end process is suppose methanol, okay, this is not applicable, the air is not applicable, because in the methanol there is no nitrogen. Okay, in that case, in the methanol formation, we have to use pure oxygen. Okay, but for the case of the end application process, for the synthesis of the ammonia, we can use air. This is the things, according to the end applications we will use the oxidant. This is the process, you know, non-catalytic partial oxidation process. Okay, there is no catalytic catalyst. Okay, in the non-catalytic, this is the same simple process, you know, that one, this is the air absorption unit. Okay, air separation unit. Whether you will use the oxygen or you will use the mixture of oxygen and nitrogen, according to that you have to use air separation unit. Okay, if I use the air separation unit, we can separate oxygen for the oxidant in the case of the partial oxidant, non-catalytic partial oxidation. Okay, this is the reaction chamber. This is the reaction chamber, and after the reaction chamber, syn gas is formations of the syn gas. Syn gas is cooled down with the using of heat exchanger. Okay, then the shift gas reactions is happening. The shift gas reactions is done just to make carbon dioxide from carbon monoxide. Okay, and after that the carbon dioxide is absorbed by, basically carbon dioxide is absorbed by methanol. Okay, methanol is a very good carbon dioxide adsorbent. Okay, this is the liquid adsorbent. Okay, then the pure hydrogen gas is, after absorbing the carbon dioxide, okay, the pure hydrogen gas is produced, or you can get pure hydrogen gas. This is all the process, you know. Acha. One thing just I want to address here, for the case of the catalytic, how the catalytic reactions is formation, the catalytic formation. Actually, what happened here? This is the, in the reactor there is the support basically Al2O3. Suppose let's assuming that Al2O3, and this is the catalyst. Catalyst basically used the nickel catalyst. Suppose this is the nickel catalyst. This is very important actually for these subjects also, as well as your future study or future research also. What happened? The catalyst has a large number of the active site. The large number of the active site means here what is the functions of the catalyst? Catalyst will uh, split the reactant. Reactants means here the methane. See, okay. Here what happened? The catalyst, what the catalyst did? This catalyst absorb carbon. Carbon is absorbed by this catalyst. Hydrogen is absorbed by the catalyst. I mean the different site it is reacting. Okay, and when this site is, when the carbon is adhere to the catalyst or hydrogen is adhere to the catalyst, okay, that means this is the breakage of the bonding, breakage of uh, CH4. Okay, this is actually breaking of the bonding of the CH4. Okay, if we don't use the catalyst, the breaking of the bond breaking required higher energy, but with the using of the catalyst, catalyst can easily break the bond of the CH4. Okay, and after the bond breakage, after bond breaking, the two hydrogen, this is the molecule, this is the atomic form, lone form. Okay, the 2H will produce the hydrogen gas. Okay, the 2H will produce the hydrogen gas, and the oxygen, it will also absorb oxygen gas O, the O from the oxygen. Okay, and this carbon and O will form the carbon monoxide. Okay, this is how the syngas is produced. This hydrogen and carbon monoxide will produce by the using of the catalytic reactions. Okay, something somewhat you can gain or you can understand how the catalyst works and how the catalyst will reduce the bond breaking, reduce the energy or reduce the temperature. If we use the catalyst, the reaction temperature will be less. If we use non-catalytic reactions, reaction temperature will be high. This is the simple things. Okay, next is the autothermal reforming. Just during the starting of my introductions, during the starting of my lecture, I have told you that how, what is the sequence of our second, or what is the sequence of our lecture in the second week. Okay, this is the last part of the autothermal reforming. Okay, uh, autothermal means I have told you that there are the two process, endothermic reactions and exothermic reactions is simultaneously happen in that case, and uh, the heat is required for the exothermic reactions, sorry, heat is required for the endothermic reactions, heat is required for the endothermic reactions will be provided from exothermic reactions. Okay, exothermic exothermic reactions. Okay, that's why what happened, that's why this is that's why ultimately main target is here that the no externally heat will be produced, no externally heat will not supply more amount of the heat from the outside. Okay, that's why this overall this process is the slightly exothermic process. Overall the process is the slightly exothermic process. Kinetic of the reaction is a slightly exothermic process. Exothermic process, but we will provide the heat. Minimum amount of the heat we will provide to the reactions. But overall, if we consider the overall reactions kinetic, it is a slightly exothermic reactions. Okay. Uh, how the autothermal reformer works? Uh, the natural gas here what happen, one chamber is used, one autothermal chamber. This is one autothermal chamber. This is one autothermal chamber. The input gas is what? The natural gas, CH4 and steam, H2O, and oxygen as oxidant. Okay, oxygen as oxidant. Oxygen is also, oxygen will also help for burning or producing the heat energy, which is required for the reactions. Okay, in the first, in the initial phase, in the initial part, the combustion zone, this is the combustion zone. Okay, the combustion zone means the natural gas and oxygen will be combustible form. Okay, it will produce heat. Okay, here in that case, the both the feedstock and the fuel, both the natural gas, I mean CH4. Okay, next is the thermal zone. Here the temperature is varied from the upper part is the 1200 to 1400 degree centigrade, and lower part is the up to 700 degree centigrade. This is the 700 degree centigrade. Okay, this is how. Okay, and upper part, in the upper part, the higher temperature. Okay, the higher temperature means that the your partial oxidations will be formed. Okay, partial oxidations will be formed. Okay, then the catalytic zone, with the help of the catalytic, the hydrogen gas will also form. Okay, in the lower part, the less temperature zone, in the lower temperature zone, there is the water gas shift reactions will occur. Here is also SMR reactions is also occur, but simultaneously water gas shift reactions will also occur. Okay, this is the autothermal reformer. Okay, Acha. One thing, the flame temperature, the at the inlet, at the inside flame temperature, the starting point of the flame combustion zone, the flame temperature is above 2000 degrees centigrade. 2000 degrees centigrade. You just remember the flame temperature is 2000 degrees centigrade. That's why the combustion zone is 2000 degrees centigrade, and the lower part the temperature is gradually reducing. The lower part temperature is up to 700 degrees centigrade or 800 degrees centigrade. Uh, for the high for the high for the high temperature reactions, here always we will use brick line reactor, because brick can sustain high temperature. Brick can sustain high temperature. Okay, anywhere the reaction temperature will be high, we will use the brick for the reaction. These things you just remember. uh, this is not going into the details, but you know that the catalyst part, why the catalyst is used. The catalyst is used, why the catalyst is used, any one of you just any one of you just tell, and all of you will learn. Why the catalyst is used? It will reduce the input temperature or input heat energy. It will increase the rate of reactions. Okay, it will increase the efficiency, all the things. What is the why we will use the support? What is the function of support? Any one of you?
To not allow carbon deposition.
Exactly. Actually, suppose is designed in such a way, that if we use some basic support means alkaline support, the alkaline is less prone to carbon depositions. Okay, that's why support can reduce the coke formation. Support can reduce the coke formations, and it will the support also can provide high provide require surface area, provide high surface area. Okay, and it will also reduce the coking and supports. Okay, it will also uh, it will also, one thing is important, it will also stabilize the catalyst, stabilizations of the catalyst, stabilization of catalyst, and second is the less coke formation, coke formation, less coke formation. Okay, less depositions of the carbon means that the efficiency of the reactions will be high. Okay, always what is the how we can reduce the coke formations, less coke formations, by using the extra amount of the water vapor. This is also one process. uh, okay, here we'll discuss, let me check anyone is waiting in lobby. Whatever I am discussing, is it clear? I am not. I am not talking extra thing. Just whatever ma'am has discussed. Just I am repeating all the things. I am trying to repeating all the things. Okay. Okay. Just I am enlarging this part. Otherwise, it is difficult for you. Okay. There are three important process: SMR reaction, steam methane reforming process, and the partial oxidation process, and the ATR, autothermal reforming process. What are the autothermal reforming process? What are the basic difference? If we consider the thermodynamics point of view, this is SMR process is the endothermic reaction process, 206 kilojoule per mole. POX, partial oxidation process, is the exothermic process, like 36 kilojoule. Okay, and 800 and 800, if 800 kilojoule per mole. And ATR process is the, it is combinations of the exothermic and endothermic. We can say that the slightly exothermic process. Okay, just you remember these things from the thermodynamics point of view. Next is the heat required. Heat required is the external heat required. Here is the external heat required. That's why we will use some sort of fuel. What the fuel we will used for the SMR reactions? Here fuel is also methane. Also methane and oxygen is used for the fuel in the SMR reactions. Okay. For the POX, no indirect heat exchanger. Here the no indirect heat exchanger. Here the direct heat is provided. Direct heat is provided. That means you have seen the burner and the combustion chamber. Okay. This is the direct heat. No indirect heat means that the direct heat. Here also ATR process is no direct heat exchanger. Okay. Obviously high efficiency. Okay, this is the lower efficiency and the excess heat cannot be easily removed. Okay, because excess heat cannot be removed recovered because this is direct heat, and direct heat is used for the reactions. Okay, one thing is important also here, the hydrogen to carbon monoxide ratio, hydrogen gas to carbon monoxide ratio, this is very important. The higher hydrogen and carbon monoxide, sorry, this is carbon monoxide. Okay, 3 to 5 for the SMR reaction, this is very high. Obviously we want very higher hydrogen to carbon monoxide ratio. This is moderate 2, and this is very wide 2 to 2 to 2.5. Okay, this is 2 to 2.5. Okay, from the point of view carbon hydrogen to carbon monoxide ratio, the SMR reactions is very good. Okay, you know that the according to the end applications we will use the fuel as well as we will use the fuel such that if we required ammonia productions, then we will use the air. If we need the hydrogen, pure hydrogen, we will use the oxygen. Okay, and the reactor size complexity you can easily, this is very large, this is very complex. Okay, for that case this is smaller reactor size, this is also reactor size is smaller. Okay, and response time is important. Response time in SMR reactions, the response time is very high. It is not very dynamically very strong, but here the very short time, very dynamically very strong. I mean fast response reactions, Okay, means that the here you required very high temperature, you have to require burner. Okay, you have to require sufficient amount of the heat, then only the reactions will occur. But in the POX partial oxidation process, there less amount of the heat is it is very confined, it is very one unit reactor, all the arrangement is getting ready very easily. Okay, very short time of period. Okay, this is the response time of period. The response time should be high, means that the very dynamic. Okay, response time should be very fast. And heat transfer related things you can study, you can do it yourself. Okay, catalyst challenges also you can I have discussed some catalyst challenges. Okay, the temperature is very important. In the SMR reaction, 700 degree centigrade to 900 degree centigrade temperature required. Okay, and the pressure is required 15 to 30 bar. Okay, just remember. And the partial oxidation process, the temperature is above 1000 degree, 1000 to 1400 degree centigrade. Okay, and the ATR reaction, the temperature is little less. Okay, in the ATR reaction the temperature is little less. You just remember the three temperature range. In the SMR reaction, the temperature range, the temperature required temperature range or the reaction temperature is lies between 700 degree centigrade to 900 degree centigrade. Partial oxidations, it requires very high temperature, 1000 to 1400 degree centigrades, and pressure is also higher, pressure is required. Okay, in the ATR autothermal reforming, temperature is little lower because partial oxidations and autothermal reactions almost similar sort of reactions is there. Okay, uh, efficiency is important. What is the efficiency? Efficiency is highest efficiency. SMR, for the SMR, the highest efficiency, and this is the lowest efficiency because the hydrogen to carbon monoxide, it is how much? Only 2. That's why it is the lowest efficiency. and this is the medium for the ATR. The hydrogen to carbon monoxide ratio for that case 2 to 2.5 or 3, 2 to 2.5 or 3. Okay, this is very very important. Whatever I am discussing, this the ratio and temperature and pressure, these are the important things. You will get this type of questions in your examination. Okay, possible reactions in the direct reactor. Okay, these things you can study it. This is the same thing actually. Okay, this is the same things. I will not go into details. Okay, okay. Just I am coming to the by-forming. By-forming means that the by-forming I am taking different color. By-forming, as the name indicates, that here the two oxidant is used in the reactions. Okay, the two oxidant is used in the reaction. That's why it is called by-forming. Two oxidant is carbon dioxide and H2O. When the carbon dioxide is used, this is called dry reforming. Okay, when carbon dioxide is used, carbon dioxide plus CH4, it is produced carbon monoxide plus hydrogen gas. This process is called dry reforming. This is called when the carbon dioxide, you know, the dry gas. So okay, dry ice. Okay, carbon dioxide. From the name dry ice, you can remember when the carbon dioxide is used as an oxidant with the CH4. This is called dry 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 reforming. Okay, here the carbon dioxide is used. Here the carbon dioxide is used and water. By reforming. By reforming, by means two. Two oxidant is used. Here tri means three oxidant is used. Three oxidant means the oxygen, water and carbon dioxide. Okay, oxygen is also used. Okay, oxygen was used in the case of the partial oxidation case, and only water was used in the SMR reactions, and carbon dioxide was used. Just I am trying to write it down. Hydrogen, water was SMR reactions, oxygen was used in the partial oxidation, carbon dioxide is used dry reforming, and by reforming, at the both the water and CO2, and tri reforming H2O plus CO2 plus oxygen. This is important. Okay, this is very very important. In your MCQ questions, one may ask that when the carbon dioxide is used, this is called dry reforming, steam methane reforming, partial oxidations, by reforming. Your answer will be dry reforming. Okay, next is the reforming of the hydrocarbon. Reforming of the hydrocarbon, in the conventional heat sources was used by using the methane and oxygen. But can we eliminate this conventional heat energy sources by using the nuclear energy, solar energy or electrical energy? Okay, nuclear assisted methane reforming means that here the nuclear energy is used, or nuclear energy is used for in the reforming process. Okay, reforming process. Suppose this is the nuclear energy, and it will produce some heat energy, and this heat energy is used to make the reforming reaction. reforming reaction. Okay, but there are obviously some challenges associated with the nuclear assisted methane reforming process, because you know that the nuclear material uh, like what is the nuclear material? Just just tell me what is the nuclear material?
Maybe uranium, thorium.
Yes, uranium, thorium. The handling of the uranium, thorium, okay, plutonium, handling is very tough. Okay, and the disposal of these things is very difficult to dispose. Okay, this can be disposed, or this can be buried in under the sea water. Okay, that's why these sort of things is very difficult to implement. But if we implement these sort of things, somehow we can reduce the carbon monoxide, carbon footprint generations. I mean, somehow we can reduce the carbon dioxide or carbon monoxide uh, from the exhaust chamber. Okay. Another things also we can use as a external heat source, like solar energy. If we absorb solar energy, if we use some if we use some torch like system, okay, this will reflect the heat energy, solar energy, directly into the SMR chamber, SMR reaction chamber, and this energy is used to do to forming the reaction. Okay, and sometimes indirect heat is used. Indirect and the heat is not directly fall into the SMR chamber, reaction chamber. The heat is absorbed first by the one one medium, like air, molten metals, or molten salt. Okay, and this molten metal, molten salt, and air is heated, and this heated air is the heat. This heat is used in the SMR reactions. Here also, the one medium is used. This medium is heated initially, and this heated medium give the heat energy to the SMR reactions. Okay, and the heat energy is directly come to the catalyst bed. Okay, that's why this is a catalyst bed. Okay, okay. That's why there are the three different type of indirect. This is the direct heat. This is the allotropic, and this is the catalyst bed type heat receiver. Okay, okay. Another one is the plasma. Another one is the plasma. If we use some electricity, if we use some electricity, why will we use some electricity? For making plasma. For making plasma. For making plasma. If we make plasma in the reaction CH4 plus water gas, if we use the plasma in these reactions, what will happen? This plasma this plasma will assist, or this plasma will help in generations, or in generations of the hydrogen. More in the generation, kinetic will be high, favorable kinetic. Okay, favorable kinetic, favorable kinetic. Okay, actually, what is the plasma? Plasma is the fourth state of matter. Plasma is the fourth state of matter. How the plasma will generated? If we use, how the plasma will generated? If we use anode plus V and cathode minus V, by using two electrode. This is the electrode. This is electrode. Okay, this is electrode material, and I am supplying externally electric field. Okay, here the plasma will generated like a spark will generated, and this spark will ignite the air. Okay, ignite the air, and air molecules will dissociated into the form of different. It will dissociate. It will dissociate like electron. In the plasma there is electron. Okay, and also there are heavy particles, heavy neutron. Okay, and also electron, heavy neutron, tron, heavy neutron. Okay, and what are the other things? And ions. These electron, heavy neutron, ions will expedite these reactions. Okay, and there are three different things. This is the gliding arc reactor. This the initially the spark will produce here, and this is the next spark will be produced. This next spark. This spark will generate the electron, neutron, and ions. This ion, electron, neutrons will stay in the plasma form, and this plasma form will help the reactions, SMR reactions. Second is the dielectric type. Dielectric dielectric type. Okay, this is the corona. Third one is the corona. Corona means the sharp edge. This is also two electrode, positive and negative, but here the electrode is in sharp type. Okay, and this is the planar and this is the sharp. The corona will generate it. Okay, this is the very theoretical part, non-thermal plasma forming and the thermal plasma forming. For the case of the non-thermal plasma forming, the temperature, if the temperature of all ions, uh, ions or neutrons or electron, if the temperature of all the things, all the plasma contain, the temperature is the same temperature. Okay, this is called the thermal plasma reforming. And if the temperature is a different for the different case, this is called non-thermal plasma reforming. Okay, and this is the very simple, you can study. Okay, okay. So overall we have studied today. In the first week it was SMR reactions. SMR reaction we have studied all the process. In the second week we have studied, what we have studied? First coming hydrogen membrane reactor. This is the subjugation reactions. Next is the partial oxidations. Next is the autothermal, and some non-conventional energy source assisted SMR reactions like solar and nuclear and plasma. Okay, and in the end the plasma was used for the SMR reactions. Okay. Here we will solve some MCQ questions. Sweep gas is used in dash process. In which process?
It's a hydrogen
Sweep.
membrane based
Hydrogen
Ha,
membrane.
hydrogen membrane based forming reforming.
reform.
Why the sweep gas is used? Do you know why the sweep gas is used? Any one of you?
To increase the concentration difference.
Suppose this is the membrane, and the hydrogen gas is coming inside the membrane and going outside. This is the hydrogen gas out. This is sweep gas. Why the sweep gas?
It creates pressure difference.
Exactly. This will sweep. This will sweep the hydrogen. Means that this will carry the hydrogen, and this will remove the hydrogen from here. And if the removal process is very fast inside the membrane, then the another newer hydrogen gas that is produced from the SMR reactions, okay, it will come easily into the into the membrane, and again the generations will kinetic will be higher. Okay. Okay. The disadvantages of the sweep hydrogen membrane based reforming is this: if we use the sweep gas, okay, sweep gas means you have to use nitrogen gas. What are the type of sweep? What the sweep of gas? What is the sweep gas you can use? What are the different sweep gas you can use? Hello, do you
I
know?
think one nitrogen can be used because
Ha,
it is
nitrogen can be used. Why
inert.
nitrogen will be used? Because
It is inert.
if our end application, if I want to produce the ammonia NH4, then you can use we can use NH3. We can use nitrogen as a sweep gas. Second, any other sweep gas you can use here?
Helium.
Huh?
Helium.
Helium. Okay, helium can be used because helium is a very inert gas. It cannot react with the hydrogen or like this. That's why. But if we use helium gas, then also you have to make some arrangement of separation arrangement. But if you use the hydrogen gas, if you use the hydrogen gas at a higher pressure, then what will happen? It will remove the hydrogen. It will sweep the produce or coming hydrogen inside the membrane. Okay, okay. Uh, Obviously, you have to use the sweep gas at a higher pressure. Then only the hydrogen gas also can be used as a sweep gas. Okay. If we use the carbon monoxide as a sweep gas, then also you have to use the you have to separate the carbon monoxide. If we use the carbon dioxide, you have to go through the methanol or liquid absorbent, okay, such that the methanol can absorb methanol can absorb the carbon dioxide, okay, and the pure hydrogen gas will be formed. Next questions. Coming to the next questions. Pressure required in non-catalytic partial oxidation process. Non-catalytic partial oxidation process. Non-catalytic partial oxidation process. What is the temperature? Do you remember the temperature range? Non-catalytic. 1000 to 1400 degree centigrade. Okay. The pressure non-catalytic means at the high temperature, high pressure. Okay. Always you remember above 30 bar. Okay. So your answer will be
50 to 80 bar.
50 to 80 bar. Always remember that when the non-catalytic means that when the no catalyst is used, then the temperature will be high. The temperature requirement is high, and the pressure requirement also high. Okay. Next is the for the autothermal reforming. Autothermal reforming process. This is the thermodynamically. It is slightly endothermic, highly exothermic, a thermoneutral process, and slightly exothermic process, and exothermic process. What will be your
Slightly,
answer?
C. C.
slightly extra.
Okay. This is thermoneutral process. Thermoneutral. Why the thermoneutral process? Because here in both the endothermic and exothermic process is happening inside the reactor. That means, and do you know how we will adjust? How we will adjust? If I ask you one question, how you we will we will adjust um, the outside or requirement of the heat in the endothermic reaction or exothermic reactions, heat will be released. How we will adjust the temperature temperature of the reaction, temperature of the SMR reactions or partial oxidation reactions or autothermal reactions. Basically I am talking about the autothermal reactions. How you will adjust the temperature of the autothermal? If I wish to react the autothermal reaction less temperature, suppose 600 degree centigrade. Okay, not 600 degree centigrade, 700 degree centigrade. Okay, you can adjust the reaction temperature, can be adjusted by oxidant and methane. Oxidant is the oxygen and the methane CH4. The proportions of the oxygen and CH4, the different proportions, if I take different proportions oxygen and CH4, the different ratio will produce the hydrogen divided by CO, and the different temperature is required. The temperature, optimum temperature will also different. Okay, so whatever your input is, okay, according to your input you have to decide your the reaction temperature will be decided, or the hydrogen to carbon monoxide ratio will be decided, I mean. Okay, uh, fourth questions, coming to the fourth question, hydrogen to carbon monoxide ratio in dry reforming under ideal conditions. Under ideal conditions, what will be the under ideal conditions, what is happening? Do you know the reactions? Dry reforming ideal reactions is what? CH4 plus,
C- CO2.
dry reforming means that the carbon dioxide,
Yes.
it is generating carbon monoxide syngas and hydrogen gas. Just do a balance. Okay, this is the CH4
To CO plus OH2.
this is 2. Okay, is it okay, or 2 hydrogen na?
Yeah, 2 hydrogen.
2 hydrogen, I think this is okay. Okay,
It would be
so
one.
hydrogen to carbon monoxide ratio, just you can find this hydrogen to carbon monoxide mole, this is 2 divided by 2, it is coming 1. Okay, this is how you have to remember actually. Okay, next, and next is the question number 5, which type of carbon is not formed in dry reforming process of methane. You have studied that there are different carbon formed in the dry reforming process. One was whisker carbon, it is formed in the dry reforming process. This is actually this is the difficulties, most difficulties part, the whisker carbon makes the reactions more difficult. Okay, pyrolytic carbon and the gum carbon and lonsdaleite, which one will not form in the dry reforming process?
D.
Whisker carbon is formed what?
D.
D. Okay. Pyrolytic carbon is also formed and gum carbon is also formed. Okay. Next, sixth. Direct heated type receiver has dash as compared to indirect heat type receiver. High temperature, low efficiency, poor heat transfer, low temperature. Direct heat type receiver means that the direct heat means that the this is the solar torch to SMR reactor chamber. This is SMR reactor chamber. This is the direct heat is falling in the SMR reactor chamber. Has dash
High
as
temperature.
compared to the indirect heat.
It would be high temperature because of direct heated type receiver. The temperature would be high.
This is the temperature will be high. Okay, this is the temperature will be high. Next, what is the conversion percentage of the methane using plasma? What is the plasma? Actually, plasma has a
In
very high efficiency.
98%.
Always
yeah,
remember
,98%.
plasma has a very high efficiency. What the plasma consists of? Plasma consists of, I have told you, the plasma consists of electron. Okay, electron, proton, I mean neutron. Okay, neutron, and another one is the ion. Actually, it plasma means that the ionization form of air. Okay, ionization form of air, ionization form of air. This ionization form of air in the plasma state will help the SMR reactions very good. Okay, that's why the efficiency, the conversions of the methanes into hydrogen gas is very large. That's why 98% conversion, 98% conversion. Okay, that means efficiency is also high. Question number 8. What is the temperature of a flame in burner region in the ATR process? In the ATR process, what is the ATR process? This is the combustion, the initial, this is the combustion chamber. Here the flame is created, the flame temperature is above 2000 degree centigrade. Okay, and gradually the temperature is down, the temperature is up to 700 degree centigrade at the bottom of the reactor. Okay, okay. 9. What is the reactions of the enthalpy of this reaction? What is the reactions of enthalpy of these reactions? This, what is this reactions? Do you know? This reaction is what? This is called dry
Dry
reforming.
reforming.
Dry reforming. I told you that the dry reforming means that the carbon dioxide is used, and you know that the dry ice, when how the dry ice will form. Any one of you? Do you know the dry ice? How the dry ice is? Why the? What is the utilizations of the dry ice? Why the dry ice is used? Where the dry ice is used? Give me one example of the dry ice applications. Dry ice applications example. Any one of you? Anyone
In
from the
food processing, it is used in medical field also. It is used.
but I don't know in the food processing or medical processing, but one common example is the fire extinguisher process, fire extinguishing. Okay, in fire extinguishing, one cylinder is there, red cylinder. This is the carbon dioxide is stored in the solid form. Okay, uh, solid form, uh, lowering down the temperature of the carbon dioxide. Okay, and this carbon, if we spray, suppose any places, burning places, any burning place, if we spray this carbon monoxide, dry carbon dioxide, okay, dry carbon dioxide, this can help in extinguishing the fire. Okay, this is the applications, or it's maybe in the food industry or medical industry. I think medical industry may be useful because what is the applications in the medical industry? Do you know? I don't know.
Yeah, where moisture is critical and for maintaining the lower temperatures, dyes are used. Similarly for food also.
Yeah. Moisture is very critical for the case of the operations like different instrument. Okay, first of all, this instrument should be autoclave. I mean, all the germs should be removed, and then this should be stored in such a way that it cannot contaminated with the water vapor contaminations. I don't know, but this may be used. Okay. Okay. Coming to the question 9, what is the enthalpy in this reaction? Dry reforming.
It's a 247 kilojoule per mole.
Ha. 247 kilojoule per mole. 247. Okay. Just to remember. This is exothermic or endothermic reaction.
It's endothermic.
Endothermic. And SMR reactions.
It is also endothermic. SMR is endothermic.
Ha. And partial oxidations.
So partial oxidation is slightly exothermic.
Exothermic, yeah.
Slightly exothermic, like 36 kilojoule per mole. Okay, you just remember this numeric value because sometimes questions will come and you will fumble, but you have to remember these. Just today you will make one note, short note. These the just write down the formula, just write down the chemical reactions and temperature and the energy enthalpy. Okay, enthalpy of the reaction. 10th, which other oxidant is used along with the steam in the ATR process, and name of the oxidant also. You just try to make one table that the reaction name, first the reaction's name, then the which is the oxidant is used, then the temperature, what is the pressure, eh, and what is the production, what is the product, and what is the enthalpy. This is this endothermic, exothermic. Make one table. Okay, make one table. If we two or three, how many reactions? How many reactions? 4 5 reactions and one secondary reactions like methanation reactions and gasification reactions and methane decomposition reactions. These reactions also you include in this table. Okay, this is very beneficial for you actually. Okay, the hydrogen production reactions, SMR reactions, dry reforming reactions, ATR reactions, and partial oxidation reactions, and methanation reactions, gasification reactions, water gas shift reactions, put all the reactions here, and what is the enthalpy, and what is the reactant used, and what is the all the things you mention, all the things you just note down, okay, for your practice purpose before exam. It will, in the exam it will helpful. Okay. Okay, 10th questions. What is the which other oxidant is used along with steam in ATR process? In ATR process, autothermal reformations.
Oxygen.
CO CO2.
CO2 तो
D.
dry reforming.
CO2 is
Oxygen.
for dry forming.
Oxygen and air.
Oxygen or
CO2,
air.
this is
Oxygen
oxygen or
or
air.
air.
Okay, this is oxygen or air. CO2 or dry reforming. This is not. And nitrogen is not used as a oxidant. Okay, and helium is inert gas. It is not also used. Okay. Uh, Next, this numerical already ma'am has discussed, but I am thinking that this numerical should be understood by you. Okay, how the what is the approach of this solving this numerical? Okay, that's why I have taken this numerical. Okay, what is the approach actually? I think this numerical. Have you understand? Have you gone through this numerical? Have you practiced this numerical? Hello. Have you practiced this numerical?
No, sir.
No, just
No.
I am just I will show you how what should be the approach. Okay, just I am copying, just I am trying to explain the ma'am's uh, what how the ma'am is how the ma'am has explained. Just I will also tell you the similar way, but just if we do repeated way, the your practice will be high. Okay, and you can remember it for a long time. Okay. First thing, just study the go through the numerical. Okay, go through the problem in the steam methane reforming process. Okay, the feed gas compositions is given below. The feed gas compositions, what is the feed gas compositions? Feed gas means that the feedstock. Feed gas compositions means that the feedstock. This is the feedstock, and this is the reaction chamber, and this is the outlet gas. This is the feed gas mean I can say this is the inlet. Okay, this is the outlet. Okay, the inlet inlet is the methane, ethane, carbon dioxide, and nitrogen. And outlet will be you have to consider what will be the outlet. What will be the outlet? In outlet gas, inlet gas, it is methane. Methane means CH4, and ethane means higher order fuel. Okay, C2H6. And next is the carbon dioxide, and another one is the nitrogen. And outlet, what will be the outlet? Just tell me, what will be the outlet product?
CO plus H2.
Outlet product will be obviously first options will be hydrogen. Okay, and second options will be obviously CO, carbon monoxide. This is the outlet we know. And I told you that the nitrogen is not appearing, or nitrogen is not reacting in this SMR reactions. So nitrogen will remain as it is. So outlet nitrogen also will coming. And another one, carbon dioxide will also produce. Okay, and another thing, higher order fuel may be completely degradation, or may stay little amount. So C2H6, as it is let the carbon ratio 3, the exit gas temperature, this is the equilibrium constant, okay. And water is used here, actually here water is also used, because water will reduce the coke formations. Obviously the outlet will be also water, some part of water, okay. These are the outlet gas and these are the inlet gas, okay. We have to see what is the mole fractions of the inlet as well as outlet mole fractions, okay. How can we calculate the inlet and outlet of the mole fraction? Here the given mole fractions is just make one table, make one table in such a way that I am writing different color. This is the approach, just I am telling about the approach, okay. This is, you have to first make one table CH4, all the gas C2 C2H6, carbon dioxide, water vapor N2, carbon monoxide, hydrogen, okay. This is the inlet mole, and this is the outlet mole. What is the inlet mole? CH4, it is already given in the questions, 0.95, and C2H6 0.03. Are you getting me? And carbon dioxide 0.01, and water it is not given, okay. And nitrogen 0.01, or carbon monoxide inlet there is no carbon monoxide, okay. Let's assuming that there is no carbon monoxide in inlet and there is no hydrogen inlet, because we are producing hydrogen. Is it clear? This line is clear?
Yes, yes, yes.
Okay. Next is the outlet. What is the outlet of the CH4? As we know, all the methane conversions is not happen, all the methane conversions is not done in the SMR reaction. So something will be remain as a methane and something will converted into hydrogen, okay. So let's assuming that some portion the remaining methane will be x amount of the x mole methane will coming out, okay, from the reaction chamber. And let's assuming that for your simplicity, okay, not for your simplicity, just I am telling about the simplicity, let's assuming that the ethane will be wholly consumed, okay, and the outlet ethane will be 0, okay, outlet ethane will be 0. Why I have taken outlet ethane will be 0? Means that the higher hydrocarbon will be 0, because steam methane reforming process it occurs above 700 degrees centigrade, but higher hydrocarbon always breaks around 400 degrees centigrade, 500 degrees centigrade, or some pre-reforming process is done before the SMR reactions. In that reforming process, all the higher hydrocarbon process is converted to the methane. Then the methane is used in the SMR. Then hydrogen will be produced. That's why we have assuming that all the higher hydrocarbon is produced into methane. Methane. That's why the higher hydrocarbon out is zero. Means that in the output there is no higher hydrocarbon. There is no ethane. Okay. This is okay.
Yes, yes.
Okay, but carbon dioxide, there is some amount of the carbon dioxide. Okay, you have to see. Okay, okay, there is uh, some amount of the oxygen, water vapor also outlet, but nitrogen will not appear in the reaction. It will remain as usual. This the blank. Whatever blank I am keeping here, this you have to calculate. Actually, this you have to calculate. X value also you have to calculate. Okay, X value also you have to calculate. Okay, next carbon monoxide is also you have to suppose let carbon monoxide is I will take only two uh, hmm, I will take two xy independent variable. Okay, two dependent variable. Okay, and hydrogen I will write it in the terms of the dependent variable. Okay, okay, this is your questions. Actually all this is the scenario. You have to find out all the you have to find out this value. You have to find out this value. You have to find out this x value. You have to find out this outlet value, this water gas outlet value, this value, and what is the hydrogen mole value. Okay, so what are the given in the numerical problem? It is given that the steam to carbon ratio, the steam to carbon ratio is 3. Okay, the steam to carbon ratio 3. That means H2O divided by carbon is 3. Oh, sorry. Okay, this is 3. So we have to write down. We have to write what are the different equations, different reactions happening in that problem. Okay, for that I have to make. I have to take one extra white page. Okay. Just let me add some new slide. Okay. What are the different reactions, SMR reactions? Acha. This is the SMR reaction. This is the SMR reaction. What is the SMR reaction? CH4 plus H2O. How I am calculating? What should be the approach? Just to remember the steps. This is the SMR reactions, and this is my water gas shift reactions. Water gas shift reactions, carbon monoxide will be water gas shift reactions plus H2O. Carbon dioxide will be produces, and also hydrogen gas will be produces. This is the SMR reaction. This is you have to calculate here in the questions. In the questions, it is given that the H2O by carbon ratio is 3. I am going to calculate the what is the H2O mole, water vapor mole. Okay, what is the carbon percentage present? What is the carbon percentage present in natural gas? What is the carbon percentage present in the natural gas? In the question, it is given that the CH4 mole percentage 0.95. Okay, 0.95. Okay, and and another carbon and another and another and another carbon is present in high in C2H6. Okay, 0.03. Okay, 0.03, and another one carbon is 0.01. So total carbon mole is 0.05 0.95 plus 0.03 multiply 2, as there is 2 carbon. Okay, and plus 0.01 total carbon present in inlet gas. Okay, total carbon present in inlet gas. This is the total carbon present in inlet gas. Total carbon present, total carbon present in natural gas or inlet. Just you write inlet gas. Inlet total carbon is present. Calculation will be 0.95. This is for the CH4 mole, plus for the higher hydrocarbon this is 2 multiply 0.03 plus 1 multiply means at the for the carbon dioxide 0.01. The total value will be coming. What is the total value will be coming? 1.02. This is the C present in the carbon present in the inlet gas before reactions. We know the C value. What will be the H2O value? How much moles of water will be fed into the reactions? This is 3 multiply 1.02. This is 3.06. Okay, 3.06 mole. So water 3.06 mole water will be used in the inlet of the SMR reactions. So water, so this is water will be sorry inlet water. So inlet water 3.06. Here just I have to I will write another color. Green color. 3.06 inlet. Okay, 3.06. Okay, next coming to another part. Okay, next you have to calculate. देखो, whatever we are doing, our main motto is just to find out this value, this blank value. Okay, we will solve one by one this x value, this y value. This is our main motto. How we are solving this, how we are finding this value, this is the way. Okay, next we have to calculate the material balance, carbon balance. Okay, next we have to do the carbon balance. I am coming to the carbon balance. This is the material balance, carbon balance. This is under material balance. This is material balance. Material balance means that the input flux, whatever the carbon is entering into the reactions, entering and total carbon equals to total carbon leaving. This is the carbon, total carbon. Actually This is the carbon. Entering total carbon equals to total leaving. Total entering carbon is whatever the total carbon in entering. We have already calculated 1.03. We have calculated na. Carbon is entering 1.03. Carbon. Okay, 1.03. So we can write that the 1.02 equals to leaving carbon. What are the leaving carbon? Leaving is the leaving is the x amount, x mole. This is CH4. This is CH4. So it will be x plus leaving here is 0, x plus this is the carbon monoxide, carbon dioxide. This is the carbon dioxide. This one x plus carbon dioxide plus carbon. This is y. Okay, this is the leaving, and there is no carbon in the nitrogen, no carbon in the water, no carbon in the hydrogen. So only carbon present is here, carbon monoxide, carbon dioxide, and this one and this one. Okay, so we have to we have to make x plus carbon here present in the carbon dioxide and plus y. Just complete the equation. So we can say that the x plus x is coming from methane part plus 0 is from C2H6 plus carbon dioxide. The carbon, how much the mole of carbon we don't know, just I am writing this one, plus y. Y is what? Carbon monoxide part. Next we have to write that, we can rewrite this equation. CO2 will be, just you rewrite this equation, you will get CO2, it will out actually out, it is leaving, is out. Okay, it will coming that 1.02 minus x minus y. Okay, so this value we can put against in place of the carbon dioxide out in the table, 1.02 minus x minus y. So put the output table, carbon dioxide output table. Okay, carbon dioxide output table 1.02 minus x minus y. One by one we are calculating. I am calculating. Okay. First I will calculate in terms of xy. Next two equations will coming. Then x and y value will be calculated through the equation, solving the equations. Okay. Next value. Acha. Next for the case of the oxygen balance. Okay, what is the oxygen balance? Oxygen is coming, only the oxygen present here. What is the where the oxygen present? Where the oxygen present? I have to. I am taking another different color. Are you getting me? Hello. In carbon dioxide, oxygen is present. In water, oxygen is present. In carbon monoxide, oxygen is present. In similar way, you have to calculate the entering and leaving of carbon of oxygen. Okay, for the oxygen, just I am showing you, for the oxygen, for the case of the carbon dioxide, for the carbon dioxide it is mole equals to 0.01 mole, but oxygen is 2. So we have to multiply 2 into 0.01 plus in the input side, inlet side, plus water inlet side 3.06 plus this one 3.06 or inlet side this is 0, this is not necessary, this is also 0, and in outlet side oxygen this is oxygen. So this plus acha, this multiply 2, because in carbon dioxide there are 2, oxygen is 2. Okay, in water value there is no, I have to calculate. Okay, I will calculate. Okay, plus H2 out plus y is the carbon monoxide oxygen. Okay, in this way you have to do, you can do oxygen balance. What is the oxygen balance? Oxygen balance, oxygen balance. So for the entering part 2 we multiply 0.01 plus 3.06 equals to 2 bracket 1.02 minus x minus y plus H2O, H2O out. From that you can calculate the H2O out will be 1.04 plus 2x plus y. Okay. Similarly, you do the hydrogen balance. Hydrogen balance. Hydrogen balance. Similarly, you can do that. You can do that. Today, just you practice it. Okay. For the hydrogen balance, it is obviously entering hydrogen equals to leaving. Entering hydrogen into leaving. Okay. The entering hydrogen you can, if you calculate 4 multiply 0.95, this is for methane CH4, mole is 0.95 mole. Okay, 4 hydrogen, that's why 4 multiply plus this is 6 multiply 0.03 plus 2 multiply 3.06 equals to 4x plus 1 plus 4x plus 1.04 plus 2x plus y multiply 2 plus hydrogen out. If we calculate, you can do that. Hydrogen out will be hydrogen out will be 8.02 minus 8x minus 2y. Put all the value here. Hydrogen out you can get, this value you will also get. In this way, whatever value, all the value you are getting. Okay. Next the reforming constant, this is the reforming constant. There you know the temperature. Here temperature is the 900 degree centigrade. Just convert it into Kelvin and you will solve this value. You will solve this value. This value will coming here. This value will coming. Some value will come. Okay. What is the value? Just I have to check the value. What is the value? Okay, just you calculate this value. You just calculate the value by using calculator, and you will get this value. And you have also you have also these things you can get K reforming, K reforming means that the reforming reaction. Okay, reforming reaction, SMR reaction. Also, this is the int. I have in the last class I told you that the concentrations of the product divided by the concentrations of the reactant. Okay, here the in the another form is the in the terms of partial pressure. Okay, in the terms of partial pressure, it is SMR reactions pressure, carbon monoxide pressure, partial pressure multiply P hydrogen. It is 3 because SMR reactions we know that the CH4 plus H2O equals to CO plus 3 hydrogen. That's why the 3 is to the power. Okay, and the reaction and reactant, partial pressure of the reactant P CH4 multiply partial pressure of the H2O. Okay, and you don't know the partial pressure of the of these things, but you have to calculate in terms of mole. Okay, just you find out the calculate the total mole and you will calculate the fractions of the fraction mole fraction. Okay, if you convert it into the mole fraction, the equations will be like this. The formula is partial pressure of any species equals to mole fractions y multiply total pressure. So you will put the mole fractions of CO, okay, multiply total pressure. In the questions it is given 20, and mole fractions of hydrogen H2, it is to the power multiply 20 to the power. Okay, this is also y CH4 multiply pressure 20, this is multiply y H2O multiply 20. In this way you can calculate the K reforming and also K water gas shift. Okay, you will get this equals to, in the xy form you will get one this value, whatever value you will get from the calculator, just put this value and this equations you will get one two equations, so you will get in terms of uh, fx and you will solve the x and y, you will get the value. Okay, this is the way of the problem things you have to approach. Okay, this is the problem solving approach you should approach. Okay, hello. uh, if you have any questions you can ask me. Already it is 19 minutes past. Okay, I think you are feeling exhausted now. If you feel any doubt regarding theory and regarding numerical, you can ask me, because just I am trying to get you more understandable things. That's why in such a way I am presenting my lecture. Already ma'am has already discussed, but just I am also trying to make it just give it into realistic way, such that you can get it easily, or you can remember the things, and what is the important, what are the important, what are the sector, how you will study actually. Okay, these are the thing important. Okay, thank you, thank you.
Thank
Okay,
you.
okay.